Welcome, learners. Welcome to the session on the Internet of Things and its applications. Myself, Dr. A. Murli Rao, Director of Computer Division, Indira Gandhi National Open University, New Delhi. Today's topic is on Internet of Things and its applications. The talk is precisely on what is the IoT, its characteristics, what are various technologies involved, what are various application areas, and followed by the issues and challenges with a concluding remarks. See, learners, as you all aware that the present emerging technologies, so this Internet of Things is one of the emerging technologies. With the convergence of technologies, then the Internet of Things concept came in. Let's see that what is Internet of Things and what are its applications. Internet of Things means that it is the network of physical objects. Object is nothing but a things. Thing means that is a device embedded with sensors, maybe some device embedded with sensors, some device which is involved in IoT, embedded with software and other technologies for the purpose of the connecting and exchanging data with other devices and systems over the internet. IoT mainly aims to innovate the human-to-machine and machine-to-machine communication. As I told you that because of the convergence in technologies, because earlier there is no convergence, means that mostly the technology is device dependent, but with the advantage of convergence in technologies, the device became the independent. So that's why the Internet of Things concept came into the picture for a wider applications. When we talk about the characteristics of Internet of Things, one is that connectivity, the other is that intelligence and identity, dynamic and self-adaptive, scalable, sensing, heterogeneity, and finally the IoT system is more secure. These are some of the maybe prime characteristics of IoT. I repeat, the connectivity, intelligence, and identity, the dynamic and self-adaptive, scalability, sensing, heterogeneity, and security. Let's talk about the physical design of IoT. Generally, the design when we talk about any IT systems or the system connected with IT devices. So there is a physical design as well as a logical design. Let's talk about physical design of IoT. Each physical device or object has a unique identifier and internet connectivity. It means that the devices or the devices involved or participated as part of the IoT system. So each device should have a unique identifier. It means that at a control room of the IoT or control room of the IoT, so whatever device, whether the device is for sensing, whether device is calculating, computing or transmitting, whatever functionality is there for a device which is connected in IoT has some unique identifier. It means that the device can be uniquely identified in terms of what is a device, its physical location, its functionality, and so on. And the next one is that internet connectivity. So the main backbone of IoT is that connectivity. It's called as, so even it is a internet connectivity as IoT not confined to a one room or a one building or one area. It may be spread across even across the globe. That's why the devices are spread across the globe depending on its application. And each device is able to connect each other. For what? to transmit the data or the information. So, learners, when we talk about the physical design of IoT, so these are the two things which we have to keep it in mind. One is the device involved has unique identification and in terms of its maybe that ID number, a device number, device name, device purpose, device location, and so on, where the device is signified. The other is that the connectivity as the backbone of the entire IoT system. Now let's talk about logical design of IoT too. When we talk about the logical design, it has 5 phases, also called the IoT life cycle. It has 5 phases, phase 1, 2, 3, 4, and 5. Phase 1 is a create phase, where devices or sensors collect data from the physical environment around them. The data can be used to generate the insight that can help businesses or customers or patrons, whatever a purpose the IoT is designed for, it will fulfill that. That is a create, we call it as the phase 1 as a create phase, because that is a starting point. Say for example, say the IoT, for example, since we are using for the health monitoring of the patients, for example. So the create phase is that it will first sense the body condition, health condition of a patient. That we call it as a create phase. After that, transmit the data, then process data and so on. But anyway, in create phase as the first phase of IoT life cycle, so where the device or sensors collect the data from the physical environment around it, collect physical environment around it. The second phase is that communicate phase. Once whatever the environment collected or whatever the data collected or sensed through sensors, then in communicate phase, so where the data and the event generated are sent through the network to the desired location. In IoT, there is a starting point, there is a transit point, there is a final, or we call it as a destination point too. So in phase 2, so what we call it as the communicate phase, where the data and event generated from phase 1 are sent through the network to the desired destination. Once the second phase is over, then the third phase, we call it as a aggregate phase, where the data collected are aggregated by the devices itself. The first and second phase, first phase is to create, the second phase is to communicate to the destination. After the destination, so whatever the data collected or then it will be aggregated. The way the data collected are aggregated by the devices itself. Once the aggregation phase is over, then fourth one as analysis phase or analyze phase. The aggregated data is analyzed. Then after analysis, data analytics will be generated, and analytics are being used to generate basic patterns and control and optimize the processes. So this is a very critical phase, analyze phase, because huge volume of data being generated, but it is to be analyzed, and after the analysis, analytics to be generated. Based on the analytics, then again generate the basic patterns, control and optimize the processes. It means that, say for example, if the IoT is used for a health monitoring system of a patient or something, for example, then once the create, communicate, aggregate phase is over, and analysis phase means that whatever data collected for a person, see that what type of, by seeing the data and its pattern, see that whether person has a fever, person has a headache, person has something else, or BP high or low. So it means that really the analysis phase, really it is a very challenging phase also. But there in analysis phase, So the aggregated data will be analyzed further, then generate some analytics. Based on the analytics, then again generate some kind of basic patterns and control optimized process, so that it is easy to make decisions what to be done later. So that's why after the phase 4, so phase 5 come into the picture. That's the act phase, where the suitable actions are performed based on the outcome of analyze phase or after analysis. So this is a final thing, act phase. This is more important. See, for example, see that as I told you that just for an example of a monitoring of health monitoring of a patient or a person. So in act phase means that after analyzing the data of the health condition of the a person, then act phase is that suppose if a BP is high, then give some kind of decision that what to be done to reduce the say BP, or suppose if fever is high, for example, what to be done. It's like that, the decision making to be done. So the act phase is nothing but a decision, implementation of the decision. The decision will come at phase 4, and act phase is that implementation of the decision. So like that, we can apply these 5 phases to any activity or any service where the IoT is implemented. Just learners, just I give you one simple example for health monitoring of a person in terms of these 5 phases, like create phase, communicate phase, aggregate phase, analyze phase, and action phase. Like that, more examples are there. Can be we can correlate with these 5 phases. And let's see that what technologies have made IoT possible. In my opening remarks, learners, I told you that convergence of technologies really made this IoT possible. However, what are the technologies behind or made the IoT possible? One is that the sensor technologies, communication networks, cloud computing platforms, machine learning and analytics, and artificial intelligence. These are the 5 prominent technologies which made the IoT possible. So sensor technology, because now this technology giving or producing low cost sensors to sense, so that because it's a basic device being used to sense the environment wherever it is located or physically installed. If it is too costly, really it is very difficult. That's why of course, depending on the sensitivity, so the sensor technologies are enabling the sensors with a low cost and to capture the environment where it is. The second is that communication networks. So learners, we all know that now the communication networks are tremendous, exponentially growth. Now we are talking about 5G. Even the government of India again started its plan to work on 6G too. So 5G before 5G, so 4G, then before 4G, 3G, 2G, and so on. That is, now let's talk about 5G in terms of communication network, the 5th generation networks, correct? So the 5G is a 5th generation mobile communication network. See, I'll just for discussion's sake, I will just tell that so in 5G, the latency means the delay in transmitting the data. For example, it is that less than a millisecond, and a huge volume of data can be uploaded or can be transmitted, or it means it can be uploaded or can be downloaded. Even the speed is that, even though, so if you are traveling even a 300 or 400 kilometers per hour, even the link sustains. So, and it has intelligent mechanism too. So that's why the communication networks is another technology where the IoT is made possible. That's why, as I told you, that for the entire IoT system, communication networks or connectivity is the backbone. Now the 5G is playing a vital role in transmitting data from sensor. What I told you that, the 5 phases of logical design of IoT, for a creation phase, then communicate phase, then aggregation phase, then analysis phase, then decision making, that is act phase. So all these 5 phases, the backbone is the network. So the communication network, because each device is well connected, able to take the data, means able to receive the data, able to send the data, and so on and so forth. That's why the second technology is where the IoT possible is the communication network. Then third one is a cloud computing platform. See, learners, what I want to say that, IoT means that even the millions of devices connected and collecting the data and aggregating the data, analyzing the data towards decision making. So for that, high computing power machines are needed. So that's why the cloud computing platform supports or facilitates to compute, to analyze, to process huge volume of data and towards generating some kind of analytics, through analytics, generating some kind of patterns, where patterns are useful to take a decision making and further action to be taken. That's why the cloud computing platform means that mainly for a computing purpose. And the fourth one is that machine learning and analytics, means that mostly the machine learning is for analyzing the huge volume of data and generate some kind of analytics. So for that, the machine learning and analytics. And last one is that, the artificial intelligence, means that after generation of the analytics comes with analysis. Okay, after analytics, so some kind of intelligence to be generated or to be created. So that we call it as with the help of this artificial intelligence, so that it will make decision making easy and implement the decisions also too. So learners, these are the core technologies made IoT possible: sensor technologies, communication networks, cloud computing platforms, machine learning analytics, and artificial intelligence. Let's talk about the IoT applications and its domains. So I think nowadays, IoT is everywhere. IoT is required for everywhere, each and every applications. See, for example, because of the convergence of technology in mind, the IoT made possible. When IoT for all application areas, domains, the IoT is there. So this to list out for a discussion's sake: consumer applications, organizational applications, industrial applications, infrastructure applications, education, agriculture, and so on, and many more are there. But these are just, I listed out that some of the application areas just for a discussion's sake. Say, learners, when we talk about consumer applications, smart home, elder care, smart cities, these are all some of the consumer applications. So when we talk about smart home, assume that each and every appliance being used in a smart house is easily accessible, controllable, and make some kind of decisions too. So that's why the smart home and even the elderly care also, because at old age, to monitor the health and movements and position of the elderly people. So again, the IoT, where it comes under a consumer application. And smart cities, as we all see that even the government of India also, I think, started the smart cities concept even way back, even almost 8-9 years back. Then I think many are in a progressing stage, where smart city concept is that every device or component used in that city or in a particular area are well connected, well monitored, well controlled, and well operated for optimal use. The main purpose of smart city is that use optimal utilization of the devices or components being used in a particular location, and protect even the environment, and protect even protect from even pollution and many more. That's the concept of the smart city is coming to picture. Now another application area is the organizational applications, medical and healthcare, transportation, learners, as I told you that the healthcare, so that doctor is elsewhere, because doctor may not be, even a family doctor may not be every time with a person. Okay. But when we talk about organization, the healthcare, medical and healthcare in terms of organization applications, the doctor is a remote, but he or she has to know, continuously monitor the health condition of the person. So where, as I told you that just I made some kind of example when I talked about the logical design of IoT. So this healthcare is mostly one of the most prominent applications of IoT. And the V2X communication, it means that vehicle to everything communication. It means that vehicle to infrastructure, vehicle to network, vehicle to device, vehicle to say pedestrian, and vehicle to vehicle. So once we talk about automated vehicle, then see that when with a driverless vehicle, suppose moving here and there, for example, so what is object to that? Without making any accident or any disturbance, so the vehicle has to reach from source to destination and destination to come back to the source, correct? That is a ultimate objective. So that's why, so vehicle to everything communicate means that once an automated vehicle is going on a road, so it has to communicate the infrastructure surrounding it while going, and see that it is communicate to the network, it is communicate to various devices, and communicate to pedestrians also, and again it has to communicate to vehicles coming on the same direction, opposite direction, so left to right, and many more. So, but IoT application in terms of organizational applications, the V2X means that vehicle to everything communication is also one of the prominent applications of IoT. Then industrial application, mainly manufacturing. Maybe I think we can talk about even in the industrial Internet of Things. Main thing is that to make so industry smart. The main purpose of IoT being used in industry is that to make the industry as smart as possible. That's why even in the industry 4.0 revolution talks about the smart, to how to make an industry smart. Again, whenever we talk about smart, means that every device is being used in that system is well controlled, accessed, and used for a optimal utilization. So another is that infrastructure application like energy management, environmental monitoring. These are also some of the applications where the IoT being used, and of course education too, and agriculture. So I will just show some few slides on some of these application areas. IoT in smart cities. So smart cities use IoT devices such as connected sensors, lights, and meters to collect and analyze the data. Data facilitates to improve the infrastructure, public utilities, and services. Another is that smart cities use for a what? Smart utility meters, smart transportation, smart grid, smart waste management, and smart air quality matters. So these are all some of the areas where IoT used in smart cities. Similarly, IoT in a smart home. Generally, when we talk about home, means that what is there in a house? Generally, lighting is there, appliances are there, and see that intrusion detection means see that some unknown person should not come inside. That's why it is to be identified, detected, alerted, and smoke and gas detector. These are all when we talk about IoT in a home automation. These are some of the things where the IoT being used. like a smart lighting. It means that depending on the outside lighting or sunlight, see that the lighting can be either increase like a brighter or a dimmer or stand still, depending on the environment. Depending on the outside lighting conditions, then the smart lighting is nothing but to adjust the lighting. That is the main purpose. And smart appliances mean that whatever we are using in a house, like a refrigerator or maybe a air conditioner or a television, whatever appliances we are using in a house, means that they are all well controlled, well operated kind of thing. And intrusion detection, learners, I told you that it is for detecting some unknown people who are trying to come inside. Before coming inside, immediately it will sense and communicate or alert the owner of the house or or the people who are supposed to monitor, and send an alert and take some kind of preventive measures and smoke and gas detectors too, so that alerts can be done. Ultimately, whenever you talk about any smart grid or a smart home or a smart cities, main thing is that what are the components, what are the devices being used in it, are well utilized, optimally utilized, without any losses kind of thing, correct? And let's just see, this diagram shows that how Internet of Things for a smart home automation. See that all home appliances are there, car is there, lighting is there, some kind of ovens are there, everything is well controlled, monitored, accessed and monitored, and alerts being generated. Not only alerts, even as a fifth phase of logical design of IoT, even to implement the action too. Say for example, some unknown person is coming where you are outside the home, immediately automatically the alert can go to the local police station, alert the police, see that some unknown person is entering or near to my house, please look into that. So like that, lot of proactive things can be done with the help of IoT in terms of home automation. And see that another application area, say the IoT in agriculture. So main thing is that now this is another prominent area with the help of IoT flourishing and coming up. Precision farming, livestock farming, agriculture drones, smart greenhouses, predictive analytics, monitoring of climate conditions, and these are all making IoT, making the agriculture more smart. Ultimately, what is for purpose is that to generate, to produce more yield. That is the main purpose behind it, and to reduce the losses. Just see, the precision farming is that micro farming. Suppose no need that a fertilizers can be added the entire entire crop. Wherever some disease found, wherever some less growth found, that where there is only needed. For example, some moisture is water level, where water is less in certain area, only identify and add water to that. So like that, the precision farming is further. Just see, some picture also shows that how it looks. And similarly, livestock farming. It means that generally farmers use some cattle and just left even in the fields itself, the farmers are at home. But how to control, monitor the cattle and their how they are, how good they are, how health-wise they are. For all such purpose, the livestock farming we call it as. See, just an example that this cattle is have some kind of device embedded with what is that, with the ears, that. So where it will sense and send the signals to the farmer to find where it is, how good it is, and so on, so that well monitored and controlled. Similarly, it is for agriculture drones also. See that on top of the crop can find the crop health assessment, irrigation, crop monitoring, and many more. See, this picture shows that it will the drone which is at top of the crop can send the pictures, and so that accordingly also how good the crop is, and so on. Similarly, greenhouses. So because certain plants are not good for the outside weather. That's why some kind of microclimate condition environment is needed for a plant optimal growth. So that's why we call it as smart green homes also. So the IoT used for smart homes, and similarly some kind of predictive analytics also for in agriculture, and so on. So these are all some of the areas, especially in agriculture. Similarly, in education also, education sector has already been disrupted through ICT with online distance learning, LMS and virtual university, but better connected, more collaborative future of for education. So in education also, mainly the what education problems does IoT solve? Data collection, personalized learning, more machine, human to machine interaction, and security too. So how IoT implementable in classroom? It means that so communicate to smart whiteboards, smart attendance tracking systems, student RFID card, temperature sensors, even HVAC. It means the heating, ventilation, and air conditioning system, safe and secure system. All this, so IoT can be used or implemented as part of in as a classroom. And these are all some of the applications where the IoT can be very much useful in education. And IoT, of course, if you talk about any technology, apart from the pros or advantages of it, always there will be issues and challenges. Without addressing this, we cannot, there is no improvement. That's always, I used to say, learners is always, improvement is a continuous process. This example, I will tell you that, anyway, let me just talk about these issues and challenges of IoT. One is that, in terms of security, because lack of encryption, the device being used or data transmitted, mostly it is in a plane. So inadequate or a lack of encryption, so that the plain text will be easy to tamper or easy to capture, insufficient testing and updating, brute force and the risk of default passwords of the devices, IoT malware and ransomware, IoT botnet. These are all some of the issues and challenges when talk about the security of the IoT system. And apart from security, design challenges also there, like a limited battery life, because this works, this installed remotely. So and they will be operated based on the battery only. So, but battery has a limited battery life, increasing cost and time to market, security of the system too. These are all some of the design challenges in IoT. And deployment challenges also, like a connectivity problem, because some of the areas is well connected, but when with the moment we are going on remotely, so connectivity is also a big challenge. So that's why connectivity is one of the challenges at deployment. When we talk about deployment challenges of IoT, cross-platform compatibility, even though convergence is there, technology convergence is there, but still there is a cross-platform compatibility issue is also there, data collection and processing, and lack of skill set and skill human resource too. So these are all, that some of the issues and challenges of IoT. But of course, when comparing with the pros and advantages of IoT, of course, these are all, even but these are all give some kind of limitation, but these can be easily addressable also. See, when we talk about now 5G, when we talk about 5G, 4G has so many limitations, but in the era of 4G itself is a very success. But when in a 4G era, so 3G is again lagging. When in a 3G era, 2G. So it means that improvement is a continuous process for a better functionality and optimal utilization to produce more yield or more throughput. Maybe now we are talking about 5G, but tomorrow when the 6G come into the picture, then again 5G also will find that so many limitations. But now we are now treating that 5G is more and more advantage than what? By the preceding generations like 4G, 3G and 2G. So like that, learners, what I would like to say here is that always go for improvement for what? Towards optimal utilization to produce more throughput, more error-free throughput, and to reduce false negatives and produce more false truths. Let's see that. Anyway, I would like to learners, I hope that this session is more informative And I would like to conclude this with the interoperability and convergence of technology, the IoT going to be a prominent model to provide real-time support and services in multiple application domains. Just for discussion's sake, I listed out a few application domain areas of IoT, but I think everywhere, so in near future, IoT applications will be there. So learners, I will recap this session. I started with what is IoT and various characteristics, various designs of physical and logical designs of IoT, the technologies used in IoT, and the various application areas of IoT, and some of the issues and challenges of IoT with a concluding message. I hope learners, this is more information, but of course, always, as I told you, that scope for improvement is the scope for improvement. It means that by taking this as some kind of reference, still you can read more and so learn more. So with this, I'll conclude. Thank you very much for patiently hearing. Thanks a lot.